Good morning slash afternoon, everyone. We're just going to wait a couple of minutes for give some people a chance to join the call, and we'll get started here in just a minute. Okay, we are at 1 o'clock. We're going to get started. So again, good morning slash afternoon, everyone. Thank you for joining the call. Appreciate you taking time out of your Saturday. My name is Andrew Kaminsky. I'm the sales and marketing leader for Zirconia implants. We look forward to a very informative and insightful program. I do need to let everybody know that this webinar is being recorded and will be posted to our website in a few days. There'll be time for questions at the end of the presentation, so please enter your questions into the question feature located in the platform control panel. Our presenter may answer questions as the presentation progresses. So without further delay, please allow me to introduce our presenter, Dr. Juan P. Anfrans. For those who don't know Juan, he's a respected surgeon, and I'm proud to say my partner in Zenova Implants. Today's program will cover the topic, new opportunities for practice differentiation. So Dr. Juan, with that, I'll turn the presentation over to you.
Thank you, Andy. Good morning or afternoon, wherever you're joining us from. Today we're going to talk about zirconia implants and how they can be an addition to your practice and differentiate your practice from the rest. A couple of disclosures. I am a Chief Dental Officer and partner of the Z7 USA company and the Zenova implant system. And I also lecture in a KOL for the Straumann company as well. Now that we have that out of the way, let's talk about the revolution that we are seeing in implant dentistry, and that's the revolution of zirconia implants. They're really changing the way that we practice implant dentistry, and I think the future is clearly moving towards zirconia implants, and we're going to see why that is during the course of this presentation. But there's no revolution without an evolution, and of course, throughout human history, we've seen a number of evolutionary events that have taken place. Obviously, anything from our existence to the way that we perceive things, to music, and more recently, the way that we communicate each other will never be the same since Steve Jobs and the introduction of the iPhone. So I strongly believe that zirconia implants are changing the way that we practice and will practice implant dentistry forever. And as we'll see throughout the presentation, zirconia implants are really not only a strong alternative to titanium, but as you'll learn, they're just as good, if not better, than titanium implants. But let's start with the basics. Let's review how we obtain zirconia, how the product comes about, and how that is manufactured. You can see these three elements right here. They're very different, but they're from the same family. The raw element is zircon, or zircon sand, zirconium silicate, and that is where we're going to obtain zirconium, the metal, and then further on, zirconia, the ceramic. 80% of the zircon sand is mined in Australia and South Africa. And there's a huge mining industry for zircon. Once we obtain that sand, we can obtain the pure metal, the zirconium, via a process called a Van Arkel process. And with that, we extract the zirconium from the mineral, and we obtain a zirconium crystal bar. And then this bar can be melted to obtain zirconium rods. Pure zirconium is mainly used in nuclear reactors as containers for nuclear fuel, and also to form several compounds because it is highly resistant to corrosion. Now we can take this material one step further, and zirconium metal can go a calcination process, and at the end of this process, one can obtain zirconium oxide powder or zirconia, and this is now a ceramic and no longer a metal. So we need to be very clear that zirconium metal is very different from zirconia ceramic, and a lot of times the words are misused frequently. Zirconia, as you can see here on the right side of the screen, is obviously white, and the main difference between zirconium metal and zirconia ceramic is that it is both a thermic and electric insulator. So what has happened is that it has lost all of the metallic properties of zirconia, and we are now referring to it as a ceramic. So it's no longer a metal. A lot of clinicians will talk about metal-free or non-metallic element zirconia. I think that a more adequate word is a non-metallic material, because as you see, it loses the metallic properties of zirconia. And you can see in this chart the different uses for this material. Zircon, as we reviewed, is the raw material. Then we can obtain zirconium, the metal, which is used in construction and nuclear. And then from there, we can transform that into, the first thing is cubic zirconia, and we can see that in jewelry. And then one further transformation will be the tetragonal zirconia, which is zirconia mixed with either yttria or alumina. And this has the dental applications in orthopedics and also in aerospace. And it's used in the aerospace industry because it's a very light material, but a very resistant material. And so the aerospace industry also benefits from this material. So what's happening? Why there's such a hype with zirconia? Well, it's clear that the market trends are showing that the use of zirconia implants and the demand of zirconia implants is increasing exponentially. This particular prediction states that in about just a couple of years from now, zirconia implants will reach almost 10% of the global implant market. Quite honestly, I think that this prediction falls short, at least from what I'm seeing in my practice, and I've seen in the last 10 years since I started placing zirconia implants. We see a bigger demand for these implants, and what I'm seeing now, at least myself, is that I am no longer waiting for patients to ask for this zirconia implant. I am choosing to place zirconia implants before choosing a titanium implant. This is a very interesting survey that was done in Switzerland and Germany, which is sort of like the mecca of ceramic implants and holistic dentistry. And they asked patients a very simple question. Would they prefer, if they had to have a tooth replaced, would they prefer a titanium or a ceramic implant? As you can see, 3.5 times more patients would choose a ceramic implant. And why is that? Why are patients requesting or asking for ceramic implants? There's different reasons why. One of them is because they may believe, or they may actually have, a titanium allergy. Titanium allergy is indeed something that is occurring. You can see the picture here on the right. This is a patient that came to see me. This is very interesting. This patient was convinced that she had a titanium allergy, and she went to her local dentist and asked the dentist for an implant and an abutment, and she taped this implant and abutment on her forearm, and she was walking around with that, and she came to the consultation with me and said, "Look, doctor, you see all this redness? This is from the titanium. I have a metal allergy." Obviously, we can all see that in this particular case, the reaction was most likely from the tape being there for 2 weeks rather than the titanium. But titanium allergy is indeed something that is occurring, and as you'll see, the incidence is higher than what we may expect. The other reason is because there's a high demand for metal-free or holistic dentistry. There are patients that are seeking a more biological approach. They don't want any metals. These are the patients that are coming to have their amalgams removed, et cetera, et cetera. And there's, at least in Southern California, there's a big movement towards biologic dentistry or holistic dentistry. And then as clinicians, what's interesting, at least for me, is that we don't see the corrosion process that we see around metals like titanium, for example, and therefore we don't see the titanium particle release, which is something that we'll talk briefly about because that's another issue that we are seeing around titanium implants. So let's talk about corrosion a little bit. Obviously, titanium is a metal, and metals corrode, and corrosion can cause the release of metal ions to surrounding hard and soft tissues, lymph nodes, and peripheral or even distant organs. Studies show that these titanium particles can cause changes in the DNA of the peri-implant microorganisms, and there can be an increased risk and incidence of inflammatory disease. And actually, studies show that there are more titanium particles found in implants that are affected by peri-implantitis. So there's several studies that compared healthy versus not healthy implants that are affected by peri-implantitis, and they saw that there's a higher concentration of titanium particles in these implants. And so titanium corrosion and titanium particle release occurs, and that is quite common, and that could be the reason for some of these unexplained peri-implantitis that we are seeing. A little bit further, more on titanium particle release. This article states that this phenomenon can occur at 4 stages during implant placement or implant surgery. The first one would be during the time of implant placement. If your implant has a high torque and it's placed with a high torque, as the implant is getting screwed in, you could see some of these titanium particles just sort of leaving the surface and getting embedded in the bone surface. The next occasion is when we do implantoplasty. This has become a very popular method to treat peri-implantitis, where you take a burr and you'll basically remove the outer surface of the implant. And if you've done that, you know that there's a lot of titanium particles that sort of spread out everywhere, and it's virtually impossible to clean. Other instances could be the friction that occurs at the abutment and implant interface because of the micromotion and the micromovements. And as we talked, corrosion is a phenomenon that does occur with any metal, and titanium implants are not free from corrosion either. This is an interesting paper that talked about the incidence or review of titanium toxicity. And what is interesting is that if you look at the bottom here, you can see that in the period of between 1991 and 1995, there was about 94 publications talking about titanium toxicity. Whereas if you compare the last period of 2016 to 2018, there are now over 700 publications related to titanium toxicity. Now, this is data both from the orthopedic literature and dental literature. And in fact, the orthopedic literature is the more abundant when it comes to titanium toxicity. There's a lot of issues with hip prosthesis and shoulder prosthesis and knees. And so our orthopedic colleagues are also aware of this titanium toxicity. So much so that the FDA got involved because of all the reports that were being sent to the FDA. And in this particular study from the FDA, they got together in September of 2019, and they wanted to look at the impact of the physiological environment on metal implants. They were looking at the immune system responses to metals and clinical manifestations. And this was an advisory panel meeting that was held by the FDA. They looked at all of the reports all the negative reports that came in that talked about possible causes of titanium corrosion, including cardiomyopathy and altered thyroid function, things like headaches, vertigo, vision changes, and more frequently fatigue, rash, joint and muscle pain, and weakness. And I have seen actually a few of these patients that after implant placement with conventional titanium implants, they develop this fatigue and rash and this unexplainable pain. And it was only after we removed these titanium implants that the patients their symptoms completely disappeared. And with dental implants per se, the FDA receives about 2.2 million adverse events yearly on problems with titanium implants. And so it's not an insignificant number. And again, the FDA got involved, and in fact, titanium implants is the second most implicated category of devices that are being reported with negative effects to the FDA. So the FDA during that meeting simply suggested that there should be that we should seek a diagnostic or screening tool to test patients. And what we are seeing now is that we'll get to the point where we can very simply do a saliva test, for example, on our patients, and we could see which patient is perhaps more prone to or more sensitive to titanium implants. Now, let me make it clear that I am not a holistic dentist, and by no means I am saying that titanium implants are bad. Obviously, we've been placing titanium implants, and I continue to place titanium implants. We've been doing this for decades. We've treated successfully millions and millions of patients, but we are starting to see some of the issues that can occur with titanium implants, and definitely there are patients that are going to be more susceptible to these issues. So in that same survey that we were talking earlier, they also asked patients if they were willing to pay more for ceramic implants. And in most instances, ceramic implants are indeed more expensive than conventional titanium implants. And as you can see on the survey, patients are willing to pay more for this tooth-colored implant. And they would even be willing to wait longer for their treatment if that was the case. And as you'll see, it is not the case. We wait the same amount of healing period for zirconia as we do for titanium. But patients stated that they were willing to wait longer if needed. And patients are really looking for this type of treatment. I mean, there are several websites where you can type in the area that you are living in, and it'll populate the clinicians or clinics that are offering ceramic implants. And I guarantee that the patients are really active online, even on social media. I've had several patients contact me through social media, patients from out of state, out of the country. And so patients are really looking for these types of treatments. And this is this is evident at least in the U.S. market. You can see the amount of implant companies that are now offering alternative to titanium, so ceramic implants. The first company in the U.S. to offer that was the Z Systems company, and then in the early 2000s, the Cerud company followed, and then it wasn't until 2016 that the Straumann company, now we are seeing a major implant company, started to offer zirconia implants as well. And then from there, Novo Biocare, Zeramex followed, and some of the more recent companies, TAV Dental, which is an Israeli company, Neodent, a Brazilian company, which I don't know if they're FDA approved yet, SDS Swiss Dental Solutions, and obviously our company, Zenova. We just recently received FDA approval. So the market is responding to this increased demand, both from patients and clinicians, and you can see now a number of companies offering an alternative to titanium. So what's so good about zirconia? What data do we have? What does the science show us about zirconia? Well, in this preclinical study in mini pigs, they simply compared the osseointegration time between zirconia and titanium implants with a similar roughness and surface pattern, as you can see in the two images. And they saw that there was similar healing time at 6 to 12 weeks and healing pattern. Therefore, zirconia showed the same capacity for osseointegration as titanium implants. And at any of the time points, they did not find any statistically significant difference from the control group. So zirconia implants, they heal just as well as titanium implants. They have the same capacity for osseointegration. There's absolutely no difference between zirconia and titanium. Obviously, these implants are intended to replace teeth that are going to be under function, and a number of biomechanical studies and laboratory studies have been done on zirconia implants, and these show similar stress distribution than titanium implants. They have high flexural strength. It's favorable for fracture resistance. They're resistant to wear and corrosion, which is really important, and obviously they're able to withstand occlusal forces. Now let's look at some of the prospective clinical studies. These were done. These are from the Straumann company after they launched their one-piece implant. In this particular study, 1 year follow-up, only one implant was lost, leading to an implant success and survival rate of 97.6%. So this is very comparable to our titanium counterparts. Very important. They did not observe any fractures on these implants, and they saw very stable marginal bone levels throughout. This was a follow-up study on the same pool of patients, now looking at the soft tissue behavior around these one-piece zirconia implants. The papilla crown proportions improved throughout the healing process. Papilla crown proportion of 40% was observed after 4 years, which is according to Chu, this is full papilla fill or very good papilla fill. And there was no correlation between thin and thick biotype. And this is important because one of the biggest advantages that we are seeing with zirconia is the behavior of the soft tissue around these implants. Even in patients with thin biotype, where sometimes you would expect recession to occur, the tissue stays very stable around these implants. And as we'll see, zirconia allows the soft tissue to adhere to the surface. So there's a direct connection mimicking what we see on natural teeth between soft tissue and zirconia. This is a 5-year result now looking at fixed dental prosthesis, so bridges. These were done both in premolar and molar sites. So now we are no longer utilizing these implants only for anterior cases. We are now restoring posterior sites that are going to be subjected to high occlusal forces. There were 49 single crowns and 22 fixed dental prostheses or bridges. Only one implant was lost after 5 weeks, so an early failure or loss of osseointegration. And at the end of the study, there was a mean overall marginal bone loss of about 0.7 millimeters with a 0.6 standard deviation, this is very, very good and very comparable to what we see in the titanium counterparts. Again, soft tissue around these implants showed very stable conditions over the entire observation period. And their success rate was 98.4. So again, very high success rate, very comparable to what we see with titanium implants. And we've actually reported this ourselves. We presented this at the International Academy of Ceramic Implantology annual meeting a couple years back. We looked at the viability of zirconia implants under high occlusal forces. This was a retrospective analysis. We did this in collaboration with Dr. Al Manesh, who is very much is an advocate of zirconia implants and has been placing zirconia implants for many years here in Southern California, and we presented his data at the AIOCI meeting. So talking about soft tissue and some of the other advantages of zirconia, one of the biggest things that we see is the ability of zirconia to prevent or minimize the amount of plaque and bacteria that accumulate around implants. If you've placed enough titanium implants, you'll see that plaque accumulates tremendously around these implants, and that very quickly leads to peri-implant mucositis and then peri-implantitis. In this particular study, it was an in vitro study where they took 3 species of biofilm and human plaque samples, and they were applied for bacterial adhesion to different types of discs. And this, as you see in the image on the bottom right, they had smooth and rough titanium discs and then smooth and rough zirconia discs. These were incubated for 72 hours. And at the end of the study period, they showed that zirconia had a statistically significant reduction in all 3 species of biofilm thickness compared to titanium, and also a statistically significant reduction in human plaque biofilm formation. What this tells us is that zirconia is a more biocompatible material, less prone to accumulate plaque and bacteria. And because of this leads to a lower incidence of peri-implantitis. This is a very nice study done by Stefan Rolling, who is one of the main advocates of ceramic implants. This was a canine study. They dentulated the dogs. They allowed for a period of healing. They placed these implants, and they randomized tissue-level implants between comparing titanium and zirconia. After 6 weeks, the implants were loaded, and 4 weeks after that, they applied these cotton ligatures around these implants to induce peri-implantitis. There was an active progression of peri-implantitis for a period of 8 weeks. Then the ligatures were removed, and obviously these animals did not receive any treatment for peri-implantitis, so the disease progressed for the next 16 weeks, and then at the end they were able to analyze these implants. Just from a clinical perspective, if you see T obviously stands for titanium, Z for zirconia, there's a very different clinical presentation of the soft tissue around titanium. You can see that there's a lot more erythema, a lot more inflammation. You know that you can see this is a tissue that is really angry, whereas around zirconia implants is not as much. Now, we are not saying that zirconia implants will not develop peri-implantitis, because that's not true. And as you can see, zirconia implants will also develop peri-implantitis, but the incidence is significantly lower than that what we see of peri-implantitis. We can see that the amount of bone loss around zirconia implants is significantly less than what we see around titanium implants, and both in the active and the spontaneous progression, zirconia implants behave better than titanium implants. So because of this higher biocompatibility and less affinity to accumulate plaque and bacteria, these implants are much more resistant to peri-implantitis. And that's one of the biggest advantages that we see as clinicians in using zirconia implants. And what are some other properties? Well, it's undeniable that zirconia will integrate. There's no question anymore that zirconia implants have the same, if not better, capacity for osseointegration. This is a beautiful histological sample from Stefan Rolling again. You can see the beautiful adaptation and the direct contact between living bone and the zirconia surface. Zirconia also has less mucosal discoloration, or a better color match to the soft tissue when compared to titanium. I'm sure that you've seen a number of patients where, especially if they have a thin biotype, you can see that show through of the titanium. You'll see that gray hue. You do not see that with zirconia, and that's why patients prefer that, and sometimes clinicians refer zirconia as a more aesthetic implant because of the white color. We already reviewed the significantly lower bacterial adhesion compared with titanium surfaces. There's also less inflammatory infiltration in the peri-implant tissue compared with titanium and even gold. It is favorable for the formation of epithelial attachments and mucosal obturation. So as I was mentioning, replication of that seal, that soft tissue seal between what we see in natural teeth, we see that as well with zirconia implants. And there's a significantly increased microcirculation in the peri-implant soft tissue compared to titanium. So overall, a very healthy soft tissue around these implants, and this is one of the more attractive things, at least for me, when using zirconia implants. Now, obviously, we've seen an evolution in modern implantology, and it's, if it wasn't for Professor Brannemark, I certainly wouldn't be here, and a lot of us would not be here either. He's the father of modern implantology, and we've seen that with titanium implants, we've seen an evolution in the design, the surface treatment. But what a lot of you may not be aware is that around the same time that Professor Brannemark was developing titanium implants, ceramic implants or non-metallic implants were also being developed. The gentleman that you see here at the bottom is Dr. Sami Sandhaus, who is no longer with us. He passed a few years ago, but he was the first one in the late 60s to already look at alternatives to metals. The first non-metallic or ceramic implants used were made out of a single crystal alumina. They were mostly one piece. There was a cementable. You can see this implant here in the middle with the gold abutment. This was a cementable zirconia abutment. But the problem was that the material was very fragile. They did not perfect the manufacturing process. The materials were a little bit different, and so they had a few issues. These implants would fracture frequently, and so they really they did not last long, and they did not gain a lot of popularity. And in a way, this is why there's still today there's sort of a stigma with ceramic implants because of this negative history that the early models had. There was a break during the time where there seemed to be no activity around ceramic implants, and then zirconia came along, and it was the Nobel company, Nobel Biocare, that tested a one-piece ceramic implant. It was called the Zionite, the ZR Unite. Unfortunately, they had really bad or really negative preclinical studies, and it never made it to market. But in the early 2000s, the Nobel Biocare was already testing zirconia implants. After that, in the early 2000s as well, the Z Systems company finally received FDA approval, and then followed by the Cerut company. And then, as we mentioned, the Straumann company around 2016, and now we are seeing more and more companies launching ceramic implants. So this is a case that we treated at the office. This patient was referred to us by a general dentist. The patient was sort of like in the middle of a full mouth rehabilitation, and this is how the patient presented to us. Tooth number 7 and number 10. Were treatment planned for extraction, and the patient expressed that she did not want any metals, and she was looking for an alternative. So we said, okay, well, we can offer zirconia implants, and at the time we were utilizing the one-piece implants. So we treatment plan this, utilize these monotype or one-piece zirconia implant. This particular one is from the Straumann company, and we treated this in an immediate approach, both for 7 and 10. We removed the teeth, and then these one-piece implants were placed. You can see the abutment in place, and from here on, it's basically like restoring a tooth. So this is what many refer as the tooth replacement concept. We can place healing caps around these implants. We change the provisional. Now the patient is wearing sort of a Maryland type of provisional. And then this is the final restoration after the healing period. And again, 3 months healing period. We are not waiting any longer than we do for titanium implants, and obviously a very happy patient with a very aesthetic result. And if we look at the x-rays, you can see that these implants have very, very stable crestal bone levels. And we'll even see these bone levels creeping all the way up to the to that interface between the crown and the implant. And so we are seeing an excellent, not only soft tissue behavior, but hard tissue behavior around these one-piece implants. Now, if you're a fan of the Apple company, and we talked about the evolution that we've seen over the years, zirconia implants are also evolving, and the biggest change that we've seen is the introduction of two-piece implants. This is really opening the doors for us to more complex treatments. And I'll show you a case here that we treated. This is, he's actually an orthodontist that came to see me, had a couple rounds of ortho and an apical surgery on tooth number 8. And you can see there's a fistula, and now this tooth has to be removed. And he was also seeking for a ceramic alternative for tooth replacement. So we have the ability to plan digitally and utilize the digital workflow just like we do with titanium implants. So again, no different there. And this is what we did here. We planned our implant. We see that where the tooth will be extracted, there's a periapical radiolucency with some deficiency, but we are planning, or our goal is to place this implant in an immediate approach and temporize immediately. So we utilize the planning software, we fabricate our surgical guides, the tooth is taken out. You can see that the tooth had the apical surgery performed. We curette, obviously, we debris all the defect, and then we follow our guided surgery protocol. Via tunnel approach, we are going to dissect and place a resorbable collagen membrane. We have drawn some PRF from the patient and prepared this sticky bone graft. We're going to place that on the facial to rebuild that buccal bone that has been lost. And we are now utilizing a two-piece implant. This gives us the ability to deliver a screw retain restoration, which we are more familiar with. And for some cases, it might be a better indication. Implant is placed in a guided fashion. We have a provisional that is prepared chairside. Now we can have this provisional prefabricated, but this was the early stages of this digital workflow. And here's the temporary restoration in place. This is an immediate post-op x-ray. And now we simply wait 3 months, same amount of time that we wait with titanium implants. We can see that the soft tissue has healed very nicely. We have really good contours of the soft tissue. Now we can take an impression. You can either follow the digital protocol, you can use your intraoral scanner, or you can take a conventional impression. In this case, we did both. We did a custom impression coping and a digital scan. And then the lab takes that information, they do their lab design, they do their cutback, and then we're able to have a screw retain restoration. This is what we call a screw-mented restoration, which basically the restoration is cemented onto the abutment, and then it's delivered via screw retention. And this is the final restoration. Obviously, it takes a group of people to deliver a case like this, and all of the credit in this particular case goes to the people that you see here at the bottom, the prosthodontist, restorative dentist, the lab technicians. I mean, they did a fantastic job, and the patient was extremely, extremely happy. Where you can't even tell that there was a tooth replaced in this case. But patients seeking for these types of solutions are not only missing a single tooth. We are seeing more and more patients that need edentulation, or they're missing teeth, and they want full arch reconstruction, like an all-on-X type of procedure. And so the two-piece systems that we have now allow us to perform these types of procedures just like we do with titanium implants. This particular patient had terminal dentition both on the maxilla and mandible. We edentulated and we placed 6 implants per jaw. You can see the upper jaw here. This is the panoramic x-ray. We did not forget that molar. We kept that molar so that the patient could have some sort of posterior stop. And the patient is currently on prototypes. We have not yet finalized the prosthesis, but you can see how we can follow the same protocols that we do with titanium implants, we can now do with our two-piece implant systems. And obviously the patient, this completely changed her life. The patient is extremely happy, and she's only in temporary use right now. So, there's a lot of questions as to the feasibility or the clinical application of these zirconia implants, and are they stable? Can we use screw retain restorations on these implants? And there's a number of papers that show that this indeed is possible, and there's absolutely no issues. You can see that the fracture tests here resulted in mean forces of about 350 newtons for the simulated incisor specimens, and over 5,000 newtons for the simulated molar specimens. I mean, these implants, there's no doubt that are able to withstand occlusal forces. The stability of the connection between the crown and the implant seems to be comparable between zirconia and titanium implants. And very interesting, if you look at the chart here, talking specifically about implant fracture, you'll see that the first group, the TM group, that's titanium molars. In this particular study, they saw 2 fractures of titanium implants in molar positions, whereas zirconia in the molar position, as you see in the bottom, there were no fractures that were observed. Only 2 incidents of crown loosening and 1 screw loosening. So again, it is clear that these implants, they integrate well, the soft tissue behaves well, and they're able to withstand occlusal forces. So there should be no doubt that these implants are able to be used suitable for clinical application. So from a clinician perspective, we know that there's comparable osseointegration. We talked about the soft tissue. There's good biological response. There's good aesthetic outcome, but still some clinicians believe that the mechanical stability is not there. And I think some of it has to do with historically what they saw from these ceramic implants, these early models of ceramic implants where they saw a lot of fractures. And I think a lot of people are still scarred by that, and they're a little bit hesitant to move into zirconia implants. Obviously, fractures can occur, just like I've seen patients break titanium implants. You'll see patients break zirconia implants as well, but a lot of it has to do with treatment planning and execution of the cases. We see some of these cases where they placed a narrow diameter zirconia implant to replace a molar on a patient that's a bruxist. I mean, you wouldn't do this normally on titanium implants. So, you want to use the same clinical judgment when you're treating patients with zirconia implants. So we talked about the evolution of implantology. We talked about the change in the material, the manufacturing of these zirconia implants has changed significantly to the point where now we are seeing implants that are being manufactured by injection molding. This is the latest technology in manufacturing of zirconia implants. So traditionally, the zirconia implants would be manufactured by pressing, whether it was unidirectional pressing, as you see here. Cold isostatic pressing was the next advancement, where you see the pressure coming in from all angles. But both of these methods left what's called compacting defects. And as you can see here, you'll have these little pores or these little holes. And this was the weak link in this manufacturing process. And that's why we saw some of these fractures. Now, this evolved to what we now know as hot isostatic pressing. And this is what I would say 90% of the implants that we have in the market today are manufactured by hot isostatic pressing. And this eliminates these voids or these gaps that were happening during the compactation process. Once this material, once the zirconia has been pressed together, the rest of the manufacturing is by subtractive methods. So we obtain these zirconia rods, and then it follows the conventional production systems like titanium implants follow, for example. These rods are milled. There's an elevated quantity of residues. It's a high energy cost of manufacturing. There's contaminants that can be introduced. And then after that, the material has to undergo additional surface treatments to obtain the rough surface, whether it be sandblasting or acid etching or a combination of these. And we know that these processes can leave residues behind. And this is something that the Clean Implant Foundation has been looking at for years now. this manufacturing process, this subtractive method to create these rough surfaces, can leave these impurities on the surface of the implants. Talking about injection molding, it's interesting to see that the method itself was developed in 1938. Karl Schwarzwälder, who's considered the father of ceramic implantology, ceramic injection molding, developed this method where a ground non-plastic ceramic material together with a binder combined with pressure and heat had the ability to be able to sinter together into different shapes. And the first application of this was actually in the automotive industry to manufacture spark plugs. And this was a German patent. And we saw that the first application of this injection molding was in the automotive industry. Ceramic injection molding allows us or gives us the ability to obtain ceramic parts with very complex shapes, with internal or external gears, undercuts, hollows, cross holes, very, very complex shapes in a very repeatable method. You basically have a mold, the material is injected just like you would do for plastic molding, for example, and then the end result is a very repeatable end product. The process, the simplified way is that you have a powder, the zirconia powder. This comes in a grain, and then you have an organic binder. This is mixed and netted together. You obtain what's called the feedstock. That's the raw material. Once you have the powder and the binder together, that's called the feedstock. And then you have these prefabricated molds. In our case, they're shaped into dental implants. Then the binder is removed, and then it is sintered. And at the end of this process, you obtain your final shape. The grain size, there are very specific ISO grain requirements. It should be 0.4 microns with about 0.2 micron standard deviation, and all of the companies have to follow this ISO standard. You can see here some of the companies what the grain size of zirconia is. It's typically around 0.4 or so, as you can see. Our implant system, the Zenova implant system, is at 0.4 microns. Everybody has their own secret sauce, let's say, but we all have to follow this ISO standard. And this secret sauce, there's a lot of elements that determine the density, hardness, and the shrinkage rate of the dental implants. All of these that you see here on the left can have an effect on the final product. One of the more important ones, perhaps, is the sintering temperature. A lot of the research goes into the amount of the temperature that is applied to the manufacturing process of these implants. And you can see here, that we can play with different pressure, different temperature, different time, and you can see that the grain size will vary depending on all of these parameters. The density, again, not only the grain size, but the density of the material will change depending on the different parameters, as we said. And again, each company has their own method. Our particular company, our internal studies showed that in the dynamic loading test was higher than the competitor monotype. So this is for the one-piece implant. Our proprietary method showed higher bending moment and maximum load compared to one of the competitors. And again, ceramic injection molding allows us to manufacture complex shapes. So in this case, we don't need any additional manufacturing process to obtain the rough surface, for example. So the mold has the macro, micro, and nano characteristics of the dental implant, where the porosity or the nano surface is within the mold. And then once the implant comes out of the mold, it is all ready to go. You don't need any additional chemical or sandblasting treatments to obtain that rough surface. It is already in the mold and it comes ready to use. So ceramic injection molding is significantly different than your conventional manufacturing process. There's less energy production, there's less waste, there's no need for post-processing surface treatments, as we mentioned. It is therefore more environmentally friendly, and because of that, there's a significant reduction of the manufacturing cost, which means that we can offer these implants at an affordable price for patients. I can tell you, a lot of patients are not able to afford the higher cost of ceramic implants. And so ceramic injection molding allows us to provide a material that is suitable for clinical use, but at the same time affordable for patients. Now, this is a new technology, and so therefore we do not have a lot of clinical data on ceramic implants manufactured by injection molding, but we are working on gathering some of that data. This is probably one of the better studies that are out there. This is a non-inferiority test, meaning that all they want to see is that the implant is comparable to a titanium implant. They were testing these two-piece titanium ceramic implants. This is the Neodent company. This was in an animal model. This was mini pigs, and you can see from the surgical photographs, they placed 3 implants, titanium, and 3 zirconia. And just to simplify, they saw at the end that the ceramic implants manufactured by injection molding were equivalent and non-inferior with respect to bone integration, bone formation, and alveolar bone level maintenance when compared to titanium. I mean, it is clear, again, that these implants integrate well, they're able to maintain bone, and there's absolutely no difference with titanium implants. We ourselves are also gathering clinical data. Obviously, we want long-term follow-ups on these implants, and this is the results of a multi-center retrospective analysis with up to 3-year follow-up. This is with our colleagues, Dr. Reinpert and Dr. Condomi and Dr. Beltrao from Argentina and Brazil. Our company is based in Argentina. That's where all the research and development is taking place, and so all this clinical data is from our South American colleagues. This is the Zenova one-piece system. Like other one-piece systems available, you have a bone level, and then you have a tissue level portion of the implant. The implantable surface, the bone level surface, has a roughness of about 1.4 to 2.6 microns. So this is a moderately rough implant surface. It has a variable thread diameter, and it is self-tapping conical design. The tissue level portion above the bone level, that is a 1.8 color of polished or smooth zirconia. And then the abutment, which is designed for digital workflow, has a roughness of about 2.5 microns, and this facilitates the mechanical retention for cementing. Again, it's manufactured by ceramic injection molding, and because of that, the roughness is already embedded in the mold. This was a multi-center study with a 3-year follow-up. Your typical inclusion and exclusion criteria. A total of 469 patients were treated, and a total of 547 implants were placed. So this is a significant number. 288 of these were immediate, in an immediate approach. The rest were delayed, and 276 of these received immediate temporization. And so, again, there's no difference in our treatment protocols between ceramic and titanium implants. We're able to do immediate implants. We're able to do immediate temporization. We took standardized periapical x-rays at the time of placement, delivery of the final restoration, and then at follow-up for 6 months, 1 year, and 3 years. This is one of the cases treated by Dr. Reinpert and Dr. Condomi. You can see a premolar here treated in an immediate approach, just like you would with your titanium implants. We filled the gap with the biomaterial, and then you can see the final restoration. The results: all patients tolerated the procedures well, and no complications were encountered during surgery. Very importantly, no fractures were observed. Now, there were 6 implants that had failed, 4 in the immediate group and 2 in the delay. This was failure to osseointegrate. And crestal bone measurements taken on the standardized digital x-ray showed a 0.6 to, with a standard deviation of 0.34 millimeter bone loss. So this is very comparable to what we see in the other ceramic implant studies and with our titanium implants as well, with an overall cumulative success rate of about 95%, which is a very good, a very acceptable and very good number to see with the ceramic implant. So again, we know that these implants are good for clinical use. We can treat them as titanium implants. We know that ceramic injection molding is a novel manufacturing technique, and it has proven to be a safe and effective method for tooth replacement. It offers the opportunity for mass production of ceramic parts with complicated shapes, combined with the advantages of dimensional reproducibility. It reduces manufacturing costs. This is very important, and it offers a very affordable solution for patients. And one-piece implants manufactured by ceramic injection molding are suitable for clinical use. Talking about clinical data and the acceptance of ceramic implants, this has changed significantly over the years. I'm a member of the Academy of Osseointegration, which is probably the largest, I would say the largest and most important implant dentistry association. And last year they held a summit meeting, and they had 3 separate groups. If you see, group 2 was focused on ceramic implants. And I was lucky enough to be invited and to participate in the ceramic implant group. Our group, the findings of our group were published just in the last edition of IJOMI. This was a systematic review meta-analysis on ceramic dental implants. And we asked, our focus question was, do ceramic implants show the same reliability when compared to titanium implants? Very simple question. We started with over 1,600 studies. There was a strict inclusion-exclusion criteria. We ended up with 25 studies for our review. So we wanted to, we were a little strict with our inclusion criteria. We wanted at least 1 year follow-up. They had to be human studies, no animal studies. Both one-piece and two-piece implants were included. They must measure marginal bone loss, and this marginal bone loss could only be measured with 2-dimensional X-rays, like periapical X-rays. We wanted 10 implant minimum per study, and they had to be obviously in English. At the end of the summit meeting, we reached consensus statements. This is very important because this is coming from the Academy of Osseointegration. This is the leading organization in implant dentistry is now saying that one-piece ceramic implants achieve osseointegration similar to titanium implants with a stable marginal bone level. They go even further and say that an bone gain is observed after prosthetic loading around zirconia implants. This is very interesting that we see this in the studies that we looked at. It also states that immediate loading or temporization of the implants does not interfere with the course of osseointegration. So this is a major breakthrough for zirconia implants because, again, we now have a leading organization stating that ceramic implants are similar or they behave similarly to titanium implants. So this is huge for us. Obviously, they also concluded that the evidence for the two-piece implants is rare because we don't have as much clinical data as we do for the one-piece implants. So we've seen, again, we talked about evolution. We've seen the evolution in ceramic implant dentistry. So what does the future look like for ceramic implants? Well, the Zenova company is working very hard. There's a lot of research and development happening. We are getting ready to launch the two-piece system. This hopefully will be available in the United States sometime next year, early next year, we hope. This will allow us to now expand the possibilities with our patients and treat more complex cases like All-on-X and these types of restorations. But the most exciting part is that there's a lot that can be incorporated now utilizing artificial intelligence. We are able to introduce and add micro and nanosensors to our implants that can give us feedback and monitor biological variables in real time. Things like loading, bone loss, this type of stuff is something that we will see in the future. So basically, you know, we're talking about an intelligent implant, a smart implant that can give us immediate feedback on how these implants are behaving. And so it's really exciting what's coming in the future in implant dentistry, and more specifically in ceramic implants. And obviously the Zenova company is full on board with these new developments. We have a whole team of R&D that is working night and day really hard on this. So ceramic implants, they're no longer the future, they're the present. And I think that the revolution is clear. They are changing the way that we practice implant dentistry, and the new generations are gonna embrace ceramic implants. And I strongly believe that ceramic implants will replace titanium implants in less than 20 years, without a doubt. So with this, I'll end the lecture. I thank you for joining us wherever you were. If you want to scan this QR code, this will give you information on the Zenova system. We are accepting pre-orders. We're getting ready to, as I said, we have FDA approval. We should be on the market very, very soon. Thank you very much for your attention, and I'm going to check and see if we have any questions.
John, we do have one question.
Yes.
And if do you want to look at the?
Let me see.
It's from Rodrigo Bertrao.
Rodrigo Bertrao. Yeah. Very nice. Hi, Rodrigo. Thank you for joining us. I don't see the question.
It says, does zirconia implants reduce the need for connective tissue grafts?
Very, very interesting question. Very good question. I would say in some cases, yes. I have seen plenty of cases where a patient that has thin biotype, for example, where if I were to place a titanium implant, I would absolutely have to do a connective tissue graft. Otherwise, that implant would show. And I don't need to do that with a zirconia implant because I'm not worried about the gray hue, right? So if we're talking about color, then I would say yes, it can avoid the need of doing a tissue graft. But at the same time, I would say that if the volume of the tissue is still deficient, you may still want to do a tissue graft just to improve the volume of the soft tissue for aesthetic purposes. But if you compare it to titanium, as far as translucency or show through of that gray color, absolutely, it avoids the need to having to do a connective tissue graft, which is a major advantage for patients. So I would say yes and no, depending on the situation. What else?
Okay, thank you, Juan. It does not appear that we have any other questions. I want to thank all of our attendees for their time today, especially on a Saturday. We look forward to doing many more of these, and I can't thank you enough. And if you need to get a hold of anybody from Zenova, please hit our website, zenovaimplants.com.
Thank you.
Thank you, everyone. Thank you, Juan.
Thank you.